Hello everyone, my name is Ping Wang. I'm from Department of Computer Science at Virginia Tech. Today I'm going to present our work about text-to-SQL generation for question answering on electronic medical records. First, I will talk about the introduction and the background of this work. Then I will introduce the challenges to solve the problem and further introduce our contributions. After that, I will show the experimental results of our proposed method. Finally, I will conclude the presentation. Due to the recent advances of data collection and storing techniques, a large amount of healthcare-related data are accumulated every day in hospitals in the form of electronic medical records, including demographics, diagnosis, procedures, lab tests, and medications. Typically, this comprehensive patient information is saved as a relational database in the form of multiple tables linked by patient ID and admission ID. How to assist doctors' clinical decisions by making use of this patient information is an important task in healthcare domain. One important way is to retrieve patient information directly from the database with some conditions. In order to help doctors efficiently explore the database, our work aims at developing a method which can directly translate the textual questions on EMR data to SQL queries. In this case, the answer to the questions can be simply returned by executing the SQL queries against the database. Therefore, the question answering task on the database can be transformed into the question to SQL query generation task. Next, I will provide several question answering examples. For the given tables in EMR data, we can ask questions like, tell me the primary disease and the prescribed medicines a patient may require. We can also ask, give me the titles of procedures underwent by patient Jennifer Feldham. Both questions are trying to retrieve patient-specific information from EMR data. In addition, we can also ask how many patients were admitted at emergency room. This question aims to retrieve cohort-based information. In order to solve the question to SQL generation task on EMR data, there are mainly two types of challenges. The first one is how to collect the set of questions. To the best of our knowledge, there is no existing dataset for this task in healthcare domain. Also, it is not feasible to enumerate all possible questions on EMR data. The second type of challenges is about the question to SQL generation. First, questions can be related to multiple columns. For example, what is the admission time and the primary disease of Michael Tucker? This question is related to two columns, admission time and primary disease. In addition, questions can be related to multiple tables but the specific tables are not given. For example, provide the primary disease of Michael Tucker and the procedure names he underwent. This question is related to two tables. In this work, we mainly tackle these challenges. Our contribution in this work are twofold. First, based on the structured tables in Mimic3 dataset and by leveraging the power of crowdsourcing, we create a large-scale Mimic SQL dataset for question-to-SQL generation task in healthcare domain. Second, we develop a deep learning-based model for question-to-SQL generation by handling several challenges, including multiple tables, table unawareness, multiple columns, We also consider the dependencies of different components in SQL query during generation. Next, I will introduce more details about these contributions. Before talking about how we generate the dataset, here I provide some basic information about the EMR data used in our work. We are using the public MIMIC3 dataset with de-identified patient information. We extracted 5 categories of patient information, including demographics, lab tests, diagnosis, procedures, and prescriptions. For each category, we prepared a specific table. These tables are linked by patient ID and admission ID. Next, I will talk about how we generate the MIMIC SQL dataset based on this dataset. Generally speaking, in MIMIC SQL dataset, we need to collect a set of question SQL query pairs in order to solve the question to SQL generation task. First, I will talk about the question generation. Typically, human annotation and machine generation are two ways to collect questions. However, it is time-consuming to manually generate questions. Also, the machine-generated questions are not as natural as human languages. So in this work, we mainly take the advantages of both machine generation and crowdsourcing to generate questions in 2 steps. In the first step, based on the table schema and content, we manually generated question templates. We mainly include 2 types of questions: information retrieval questions and reasoning questions. In the second step, each template question is rephrased as its corresponding natural language question on the crowdsourcing platform Freelancer. When generating the template questions, we also generate the corresponding SQL query at the same time. We incorporate all the SQL queries into this general SQL template. In this template, AGG column represents the topic that we are interested in each question. AGG operation is the operation used for the selected column. During our generation, we mainly consider 5 different values. Here, table indicates the table names that are related to the question, and condition represent the constraints in the corresponding question. During the query generation, we mainly consider 5 different operations in the condition. Here, I provide an example in MIMIC SQL. This question is related to 2 tables. Different colors are used to show the correspondence between various components. Here, the data format is a logic form of SQL query. It can be easily converted into the corresponding SQL query. After we generate the dataset, the next task for us is to solve the question to SQL generation problem. It means that given a natural language question, we need to predict its corresponding SQL query. Generally, there are 2 types of methods. The first one is the semantic parsing-based methods, which first use the semantic information in the question and the table schema to generate the logic form of SQL query. Then the logic form is further converted into its corresponding SQL. The second type is the language generation methods, which directly predict the SQL queries. The method we proposed in our work belongs to this type. Next, I will introduce more details about our method. The input is a natural language question X. Given this input question, we need to predict the SQL query Y. We adapt the language generation approach and propose a translate-added model for question to SQL query generation. There are mainly 3 steps in this model. First, we translate the question to SQL query using a sequence-to-sequence based model. Second, we added the generated query with an attentive copying meta algorithm. Finally, we further editing the query with a task-specific lookup table. Here is the framework of our CHEX model. It is based on a RNN sequence-to-sequence framework. It is composed of a question encoder and a SQL decoder. The decoder takes the word embeddings of input tokens as input and turns them into a sequence of encoder hidden states. For decoder, we combine a generation network and a pointer network to control the generation and copying. The generation network is used to directly generate the tokens that do not exactly appear in the input questions, including the template keywords, aggregation columns, condition columns. The pointer network is primarily used to generate the in-vocabulary words and put placeholders for out-vocabulary words. After generating the query, we replace each placeholder with a token in the source question by the masked attention mechanism. This is our first editing step. Here are the 2 types of attention mechanisms used in our model. For attention encoder, in each decoding step, we use a temporal attention strategy on the input question to prevent the decoder repeatedly attending on the same part of the question. We also introduce dynamic attentions on the decoder hidden state to dynamically attend on the previous generated tokens. Now, we are able to generate the SQL query for a given input question. However, it is possible that the generated queries cannot be executable. For example, for the question, how many patients who have bowel obstruct and stay in hospital for more than 10 days? One of the generated conditions in the SQL query is primary disease equals to bowel obstruct. However, this condition value does not appear in the database. Therefore, this generated query is not executable against the database. Our solution to solve this problem is to retrieve the exact condition values based on the predicted values and the table's content. We use the string matching metric lookup to find the most similar condition value from the lookup table. In general, there are mainly 2 types of evaluation metrics to evaluate the performance of the question to SQL generation methods. Execution accuracy represents the percentage of predicted queries that provide correct answers. However, it is possible that the incorrectly predicted query lead to correct answers. To overcome this disadvantage, we can use the logic form accuracy. It is the string matching accuracy between the generated queries and the ground truth. In addition, we can also evaluate the performance of each component in SQL queries and get the breakdown evaluation. We compare our CHEX method with several baselines. The cost-to-find and MCQNet are semantic parsing-based methods. They mainly predict the logic form first. While the sequence-to-sequence and pointer generator are language generation methods, they directly predict the SQL queries. Here are the results on the template questions. We can see that sequence-to-sequence model is the worst one since it cannot handle the repetitions and auto-vocabulary words. Pointer generator performs better than sequence-to-sequence model since it can copy words directly from the input questions. Cost-to-find works well for questions on a single table and outperforms both sequence-to-sequence and pointer generator methods. But it is not able to handle complex questions. Compared to these methods, MCQNet considers the dependency between components in SQL queries. It performs significantly better than other baseline methods. Compared to all these baselines, our proposed method outperforms all others, and it is 30% more accurate on average. In addition, we apply the condition value recover technique on the language generation-based methods. It can correct the errors in the generated queries from the models. We can see that it can significantly boost the performance. In order to further evaluate the performance on each component of SQL queries, we also provide the breakdown accuracy results, including the performance on aggregation operation, aggregation column, table, condition column along with its operation and condition value. We can observe that there is no significant difference between these methods on predictions of the first three components. The performance of condition value dominates the overall SQL generation performance. Our proposed method is able to capture the condition values more accurately than others. We believe that the reason is that we apply two types of attention mechanism, the controlled generation and copying technique and the recover technique in the model. These two tables provide the results on natural language questions. We can see that almost all methods do not perform as well as on the template questions. The reason is that it is more challenging for models to efficiently detect keywords of condition values in human-generated questions. But our method is still significantly outperforming others. Here we show the generated SQL queries by different models onto two natural language questions. The incorrectly predicted words are highlighted in red color. For both examples, different methods have given correct answers for the SQL template, table name, and aggregation columns. But almost all the baseline methods cannot correctly predict the condition columns and condition values. For example 1, MCQNet provides a wrong procedure short title due to its misclassification error, while sequence-to-sequence and pointer generator generate a partially correct procedure short title, but they do not have the ability to correctly predict the condition column. Similarly, for example 2, for sequence-to-sequence model, even if it correctly predicts the value ferritin for the second condition, it predicts an incorrect condition column lab item ID. In this case, the recover technique can only recover the numerical value for lab item ID instead of keeping the correctly generated condition value. This means that even if we apply the recover technique on sequence-to-sequence and pointer generator methods, they cannot provide correct condition values due to the incorrectly predicted condition columns. These results indicate that successfully recovering the condition values still requires the models to produce correct condition columns and sufficiently relevant keywords. Different from these baselines, our proposed method can generate totally correct SQL queries for both examples even without applying the recover technique. This means that our method is able to predict the correct condition values without affecting the performance of other components in the SQL query. Here we show the visualization of attention weights to provide an intuitive view about the relationships between generated tokens and the input questions. Here, different conditions are labeled with different colors. An intense shade indicates a higher attention weight. For example, for question 3, when predicting the first condition, it mainly focuses on the word female. Since this word is not explicitly included in the database, the value f in the predicted SQL query is mainly obtained by generation, where for the second condition, it mainly focuses on the word amitriptyline. The word in SQL, the same word in the SQL query is predicted mainly by copying from the input question. Similarly, for question 4, when predicting the first condition, it mainly attends on two words, elective and admission. While predicting the second condition, it mainly focuses on coronary artery. In conclusion, automated query generation for a natural language question is a challenging problem in healthcare domain. To solve this problem, we first generate mimic SQL data with question SQL pairs specifically for the task in healthcare domain. We further propose a sequence-to-sequence based model to solve the problem on mimic SQL data by first generating the targeted SQL query directly and then editing with both attention mechanism and recover technique. The proposed model is able to handle several challenges, including multiple tables, table unawareness, multiple columns. Our codes and mimic SQL dataset are available at this GitHub link. Please feel free to email us if you have any questions and suggestions. Thank you.